Here is the Audio Mechanic Project final demo with commentary. As you've just heard, this is a rifle that has its gun sounds replaced with a metasound source that generates a random note from a determined range, and that note is then scaled to a major scale and plugged into two saw waves, mixed and outputted. So what happens is every single time the player uses left click, it not only shoots out a projectile, it also generates a note to play. Here you have the ability to mute gun sounds only if the player wishes to interact with the piano. As you've just heard, right-clicking in the game activates ring modulation and it messes with the frequency. Here is a piano that the player can interact with, not only by using projectiles, but also with their own physical body. How this works is it accepts not only a predetermined it accepts a int, and that is then plugged into the frequency of a super oscillator set to a sine wave. And what this does is when you place it in the game world, it defaults to 60, as that is the frequency for a C3/middle C. And what you can do is when you place it in the game world, you are able to place multiple and just scale, just change the frequency to be the note that you want. What I did here was I just added one to each semitone up. Here is an audio stem cube. This is the main mechanic of the level, and how it works is all parts of the track. So the track is split up into 4 parts: the chords, drum, bass, and the melody. And how it works is all the audio stem files are WAV files, and all of them have the exact same length in time. And on the startup of the level, they all start playing. However, the Metasounds asset that they are linked to sets all of their volumes to 0. So although they are playing, you cannot hear them until the cube that is linked to the, let's say for example, the bass is shot by the player. It will then set the volume of that audio stem to 1. This here is the bass. As you can hear, they are both in time, not only because that's how it was designed, but also they are on a loop and they are inextricably linked to a Metasounds source asset. This here is a .wav player file cube, and it also doubles as an audio visualizer. How this works is on contact with a ball projectile, it will start playing the .wav file. It has its audio component set to, and the audio visualization is taking the output of the audio, turning it into a float, and setting the z-axis of the cube to reflect the current frequency times 50, as if it is just set to its standard output, it would not change very much. That decay down it uses a lerp function. So what happened is, to play the cube, it is to play and stop the cube, it has a flip-flop. On the first case of collision, it will start playing, and on the second case, it will not only stop playing, however, it will take the current height of the cube and, using a lerp function, decay it down to its original size. This is a use case for visualizers, as it has collisions for the player to interact with and use as a sort of pseudo elevator. Here's another elevator style. This is the final audio stem cube, and you are now able to hear the full song. This here is a reset level door, and how it works is, on collision with only the player, it will load up another level. However, in this case, to use as a reset level, it just loads this exact same level up. As you can see, all the audio stem cubes were stopped, and so was the wave player file. The song that the audio visualizer uses is called Into the Rabbit Hole, from Skullgirls' second encore original soundtrack. This here happens due purely to how fast the audio visualizer rises